Okay, good morning. Today, for pre-calculus today, I'm going to be looking at identities. So an identity is, some kind of fact about something. So if it was an identity about a person, you're finding out about that person. This would be kind of finding out about a couple of expressions. Usually it can be true. But anyway, we'll get into the proving true part in another video. I have a bunch of formulas I want you to write down. These are where we're going to start. So write these down, please. You can write them on your formula sheet. And we'll talk about which ones you can use on quizzes and tests in class, since this is a video for various different levels. So write those down, and you can hit pause. I'm going to jump back to my problems. So some of these we've gone over, and some of them we haven't. I don't think we've gone over the negative ones in the middle. But I'm going to keep referring back to these during this video and this next couple sections. And sometimes if I see, geez, I have a cosecant squared, and I would like to manipulate that. Looking back up here at your formulas, and you find, oh, geez, there's that one nice formula there where 1 plus the cotangent squared is a cosecant squared. So maybe I want to change all my cosecants squareds to 1 plus cotangents, for example. Anyway, we'll be referring back to these. So first problem is this. We're just simplifying these. There's no equal sign. So in order to simplify this, you need to know something about the cosecant. Hopefully you've learned by now that the cosecant is the inverse of the sine. So 1 over the cosecant, or 1 over the sine, is the same as the cosecant. And the sine is the same. You could always put the sine of x over 1, which means if you multiply those together, you get the sine of x over the sine of x. And anything divided by itself is 1. So that's what that one simplifies to. Okay. Number 2, tangent times the cosine. So the tangent is, do I have it written down here? I guess I don't. It's from an earlier video. The tangent, one of the definitions of the tangent is the sine divided by the cosine. And this would be the cosine of x. You can always put that over 1. So if I multiply those together, you will find that the cosines here will cancel, which leaves me with just the sine of x. And that's the answer. Number 3, cotangent times the sine. So cotangent, we said tangent was sine over cosine. So that means cotangent is that upside down. Instead of the sine over the cosine, it'll be the cosine over the sine times the sine of x over 1. Once again, when I multiply those together, when you have something in the top and the bottom of the fraction, you can cancel them, which leaves me with the cosine of x over 1, or just cosine of x. That's it. Nice. Okay, number 4. So with number 4, I am looking at 1 minus sine squared, and I'd like to change that. So I'm going to look back up at my formulas, and I don't see a 1 minus sine squared, but I do see sine squared plus cosine squared equals 1. Now that equation can be manipulated. If I took this equation and I subtracted sine squared from both sides, what I would get is I would get cosine squared of x equals 1 minus sine squared of x. And maybe I took that same equation and subtracted the cosine squared from both sides, which would give me sine squared of x equals 1 minus cosine squared of x. So that one equation's actually got 2 others built into it, so there's actually like 3 of them there. So I can switch. I'm going to use this equation. Now I'm going to switch the 1 minus sine squared into a cosine squared. So I got cosine squared of x times, now secant, hopefully you know by now that secant is 1 over the cosine. which means when I multiply this together, I get cosine squared of x over regular cosine of x, which means I got two cosines in the top. You could rewrite that as cosine of x times cosine of x. That's the same as cosine squared of x, which means one of them cancels with the denominator and leaves me with regular old cosine of x over 1 or cosine of x. And that's what that one simplifies down to. Number 5. Forgot to erase it. Cosine of negative x. So if I go back up to my formulas, once again, if you get stuck, look back at your formulas. I'm looking at cosine of negative x right there. It's the same as regular cosine of x. But notice how the sine of negative x is not the regular sine of x. That one's minus, so you put the negative sign in the front. You can move the negative sign from the x to the front with the sign. So I'm going to do those two things here with that problem. So we said the cosine is the same, stays as regular cosine of x. However, the sign I can move outside. So, that negative sign there, I can really move it in the front at this point. They're all, whether it's in the front, in the bottom, or in the side, it doesn't really matter. But what also I'm going to do is I'm going to show the person who's grading my test that I know that cosine over sine is actually the cotangent of x, and I'll put that negative out front, okay? So that's actually the best answer you can give, all right? Give it as a single function instead of two, okay? Number 6. Now, once again, I'm going to use a formula. Cosecant squared, that's one I'm looking for. Do I see a cosecant squared? Ooh, I do. I see that cosecant squared is 1 plus cotangent squared, which is great because I've got a cotangent squared in that equation. So 1 plus cotangent squared, that's what that equals, okay? And then I've also got this minus cotangent squared over there of x. So, I can write that right on top. This is equal to 1 plus cotangent squared of x. So, if I combine those together, I've got a positive cotangent squared of x and a minus cotangent squared of x. So anything subtracted from itself is 0, which means what I'm really left with is the 1, okay? Those two things cancel each other out, and I'm left with 1. Next, number 7. Sine of pi over 2 minus x. So if I'm looking back at my formulas, I see there's a sine of pi minus 2 over pi over 2 over minus x, which is the same as the cosine. And if I look at cosine of pi over 2 minus x, what I get is I see that's the same as the sine. So I can go back to my problem. So this numerator is the same as the cosine, and the denominator is the same as the sine, which means I've got cosine over sine, which is the same as the cotangent. Remember, tangent of x is sine over cosine, so cotangent is that upside down, cosine over sine. Number 8. This one's a little different. This one's a little more of a factoring problem. You see how both of those terms have a cosecant of x? So I can factor that. Here's just a quick example, of a basic factoring. If I had xy minus x, I could pull an x out of both of those terms, right? And be left with y minus 1, something like that. This is the same idea. The only thing is that I'm actually going to be pulling out a cosecant of x, which means once I pull the cosecant out of that one, I'm left with cosine squared of x. And remember, you're dividing, so cosine, I'm not just left with 0 there. I'm actually left with 1 because those will cosecant divided by cosecant is 1, okay? So that's what you're left with there. So now I've got cosine squared of x minus 1. Okay, so cosine squared minus 1, that's real close to 1 minus cosine squared, which we already said is sine squared. So there's a trick here, and the trick is if I make the sine squared negative. In fact, I'm going to do it to both sides. What happens then is, the 1 becomes negative, but the cosine squared becomes positive, and then you could change the order. So you see that this is actually equal to negative sine squared of x. And you could do the same thing with a cosine. All right, so that's a nice trick, which means this is equal to negative sine squared of x. And you're probably asking yourself why I did that. Well, the reason I did that is because I saw the cosecant of x, and the cosecant is really 1 over the sine. So this is times negative sine squared of x over 1. Okay, so I've got 2 signs in the numerator and 1 in the denominator, and of course I also have a negative. So if I have 2 signs in the numerator, one of them will cancel with the 1 in the denominator, and I'm left with the negative sine of x, and that is my answer. Number 9, a little quick. All right, so number 9. Once again, I see 1 minus sine squared, which means if I took this equation and I subtracted sine squared from both sides, I would get that the cosine squared of x equals 1 minus sine squared of x. So I can substitute cosine squared into the numerator. And now I've got 2 cosines in the numerator and 1 in the denominator, which means one of these 2 cancels with the cosine in the denominator, which leaves me with good old regular cosine of x. Okay, number 10. So I see cosecant square and minus 1, and I would like to find something other than that. So I go up to my list of formulas and I find this one, the 1 plus cotangent squared equals cosecant squared. So if I take that equation and I manipulate it a little bit so that I subtract cosecant squared from both sides, I get 1 minus cosecant squared plus cotangent squared equals 0. And then if I subtract cotangent squared from both sides, I get 1 cotangent squared equals 1 minus cosecant squared equals negative cotangent squared. So that's where I'm at with that, which means I can plug in a negative cotangent squared there. For the cosecant squared minus 1. And cotangent is equal to cosine over sine, so you'll see I highlighted this over here. Cotangent squared of x is equal to cosine squared over sine squared, right? I'm not sure that's I've ever quite explained it to you that way, but that's you can do that. Cotangent squared is cosine squared over sine squared. So I'm going to switch that. Cosine squared over sine squared. Now, and it's got a negative on it. I'm also multiplying sine squared of x over 1 times that. So if I multiply those together, the sine squareds cancel. And I'm left with negative cosine squared of x. And that is the answer. Okay. Number 11, tangent times secant. So tangent is the sine over the cosine. Cosecant is the inverse of the sine, which means it's 1 over the sine of x. So now if I multiply those together, I get sine of x over the cosine of x times the sine of x. And my sine of x's cancel, which leaves me with 1 over cosine of x, which should be simplified. Remember, cosine and secant are the inverses, so that's the same as the secant of x. Okay, and that's the answer. Number 12, this is a good one. So, there was a time where I gave you like x squared minus 4, and I asked you to factor that, and you'd go x plus 4, x minus 4, right? This one's the same idea. It's a difference of two squares. However, it's got cosines and sines in it, which means perfect square. One's a plus, one's a minus. And so I got sine squared of x plus cosine squared of x. This one's sine squared of x and cosine squared of x. Now, going back to your formulas, that one, sine squared of x plus cosine squared of x, is 1. So it's 1 times this. And so it's really just, that boils down to cosine squared, sine squared minus cosine squared. And that's it. That's as good as that one's going to get. Okay. All right. So this one, cotangent squared. I mean, I can write this as cotangent squared of x divided by cosecant squared of x. Now, if I start switching those around, cotangent is cosine over sine. So therefore, cotangent squared would be cosine squared over sine squared. Cosecant is the inverse of the sine. So remember, when you divide fractions, you flip them and multiply them. So I can go flip the second one upside down. This one stays the same. Which means I've got sine squareds in both the top and the bottom of the fraction. So those cancel. And what I'm left with is cosine squared of x. And that's what the answer is. 14. Cotangent squared of x plus 1. So that looks like something I might find in a formula up there. If I go back up to the top here, cotangent squared of x plus 1. Oh, there it is right there, right? Cotangent squared of x plus 1 is equal to cosecant squared. So I got this now. Now I'm going to simplify this. Remember, cosecant is the inverse of the sine. So that's 1 over sine squared of x. So this is 1 divided by, you could write this, I know this gets, these are the same things, just written differently, okay? Which means you flip the second one upside down and then multiply. Either way, you end up with sine squared of x as your answer. Okay, I know that. That one looked, I probably made that look more complicated than it really was, but anyway. Okay, so number 15, cosine squared over 1 minus sine of y. So I can change the cosine squared of y into 1 minus sine squared. So if I do that, I get 1 minus sine squared of y over sine of 1 minus, this one's, so 1 squared and 1's not. Now that numerator is a difference of two squares, which means I can factor it. Perfect square minus a perfect square is 1 minus sine of y times 1 plus sine of y all over 1 minus sine of y. And then I can cancel some things out, right? I've got the same thing in the top and the bottom of the fraction, which means what's left is 1 plus sine of y. And that's the answer. 16. So this one's kind of neat. I can factor out, they both have a sine of x in there, which means I can pull a sine of x outside the parentheses. And what's left in there is the cosine squared of x minus 1, okay? Now I went through earlier in the video that, the 1 minus cosine squared is sine squared. So therefore, if I switch the order, cosine squared minus 1, you get negative sine squared of x, Okay, so I've got this, which means I've got sine squared times regular sine gives me 3 sines, or sine cubed of x, and it's negative, and that's my answer. Number 17. This one's a little trickier. Tangent to the fourth plus 2 tangent squared of x plus 1. So this one's similar to y to the fourth plus 2y squared plus 1. That's a factoring problem, right? It's y squared plus 1 times y squared plus 1. Things that multiply to 1 and add up to 2 would be 1 and 1. And then the square root of y to the fourth is y squared. So that's how I'm going to go about this one, which means I get tangent squared of x plus 1 times tangent squared of x plus 1. Okay? And then if you look back at your formula sheet, you'll see that the tangent squared of x plus 1 is the same as the secant squared. So I got secant squared of x times secant squared of x. I don't need parentheses there actually, which will give me secant to the fourth if I multiply those together of x. And that is my answer. 18. So this one, that's a difference of 2 squares. If I multiply those together, you could do FOIL or box, I guess, if you like. 4 times 4 is 16. Square the front number. Multiply the back numbers together. If you square those together, I get 16 sine squared of x, which looks pretty good. However, I gotta see that there's 16s both there, which means I can factor out a 16, which leaves me with 1 minus sine squared of x. And that can be simplified to cosine squared of x. Times 16, so it's 16 cosine squared of x. That's the best answer. 2 more. So this one, I see I have some regular numbers together, so I can combine the 2 1s, and I can get a 2 out of that, which leaves me with tangent squared of x plus 3 tangent of x plus 2. So this, once again, is a factoring problem. Okay, this one's similar to this on the side. That would be y squared plus 3y plus 2, right? If I factored this, I would get y plus 2 times y plus 1. Things that multiply to 2 and add up to 3, right? Which means this is going to be the same kind of thing, except that instead of being y plus 2, it's going to be tangent of x plus 2. And instead of being y plus 1, this will be tangent of x plus 1, okay? And you know what? That's really just about as good as it gets. There's nothing more I can do with that. I was hoping to be able to simplify that a little more, but I guess you're showing that you know how to factor it. Anyway, this one. Once again, if I FOIL this out or use box technique, I will get cosecant squared of x. The middle terms will cancel. I'll be left with minus 1. And if you go back to your formula sheet, you will see that the cosecant squared of x minus 1 cosecant squared of x minus 1. If I took this one, the second one, subtracted 1, I would get cotangent squared. So that is going to be my answer. Cotangent squared of x. And that's it. That's all I got for today. Have a great night.